So in this lecture, we are going to discuss about the classification of second order partial differential equation. If the second order partial differential equation is of this type, that is R uxx plus S uxy plus T uyy plus G, which is a function of xy ux uy equal to 0. If this R, S and T will satisfy this condition, that means if it is positive, then we can say that this second order PDE is a hyperbolic type. For example, the hyperbolic type equation is uxx is equal to 1 upon c square utt, which is known as a wave equation. And the canonical form of this hyperbolic type is always of the form is u xi eta is equal to some function. If it is equal to 0, then we can say it is a parabolic type. And in that situation, we'll have a heat equation, which is an example of parabolic type. And its equation is ut is equal to k uxx, which is of this form. And the third equation is if it is less than 0, then this partial differential equation is known as an elliptic type. And the example of elliptic type equation is the Laplace equation. The canonical form of a Laplace equation is this. So this is, I can say, it is a one formula based things we need to discuss here. We are going to discuss some examples based on this classification of second order partial differential equation. So the example is this: reduce the equation uxx minus x square uyy equal to 0 to a canonical form. What does it mean of a canonical form? That means we need to find out which of this form is coming into the situation. So as per the method, we'll compare this partial differential equation with the standard equation, that is R uxx plus S uxy plus T uyy plus some function is equal to 0. So comparing equation 1, what is the equation 1? I will say it is this: 2 R uxx plus S uxy plus T uyy plus some function g of xy ux uy equal to 0, we get R equal to, R is the coefficient of uxx, that is 1. S is the coefficient of uxy, there is no uxy term is there, so it is 0. And T, it is the coefficient of uyy, which is minus x square. So this is the value of RST. Now we have to check whether which of this condition will satisfy. That means R square minus 4t is positive, negative, or it is 0. So now let us find out what is S square minus 4RT. As you know, S is 0, so it is 0 minus 4. R is 1 and T is minus x square. So this will give me 4x square, which is always positive. That means we can say that the equation 1 is of hyperbolic type. Therefore, the equation 1 is of the form hyperbolic type, or I can say just it is a hyperbolic type equation. So this is the type. So it is a classification of this second order partial differential equation. Among these three, it is hyperbolic type. Now we need to calculate what will be a reduced canonical form. So that means I need to reduce this equation into this form, that is hyperbolic type. That is the first case we have. So your canonical form should be look like this: del square u del xi del eta. So for that, you just recall my previous lecture, what we have did. We have start with, so consider r alpha square plus s alpha plus t equal to 0. That means we have considered this quadratic polynomial. Now here the value of r we have substitute here. The value of r we have got, it is 1, s is 0 and t is minus x square. So that's why it is gives me r square plus 0 into alpha plus minus x square. So that will gives me alpha square is equal to x square. So therefore it gives me alpha is equal to plus or minus x. So now take this lambda 1 is equal to x and lambda 2 is equal to minus x. So these are the two roots you will have of this quadratic polynomial. The one of them is x, another one is minus x. Now, if you recall again by the previous lecture, the next step is to find out what is dy by dx is equal to lambda 1 and dy by dx is equal to lambda 2. So now we'll start with this. Dy by dx is equal to lambda 1 and the another, so it is should be dy by dx plus lambda 1 equal to 0 and dy by dx plus lambda 2 equal to 0. So dy by dx plus lambda, that means we have it is plus x is equal to 0 and dy by dx minus x is equal to 0 because the value of lambda is minus x. Now if we find out this ordinary differential equation, the solution of this ordinary differential equation by separable variable method. That means dy is equal to, we have x into dx minus x into dx here, and here it is dy by dx is equal to x into dx, we can write. So if we integrate this will gives me y equal to minus x square by 2 plus some constant c1, and here we'll have y equal to x square by 2 plus some constant c2. So hence we have a two solution, that is y plus x square by 2 equal to c1 and y minus x square by 2 equal to c2. So these are the two roots or two solution of this one. One of the function you can take as xi, another one you can take as eta. So and from that we can convert our partial differential equation into that. So now therefore take xi is equal to y plus x square by 2 and eta is equal to y minus x square by 2. Now what we're doing is we changing the independent variable from x and y to xi and eta. So we have to convert our partial differential equation into xi and eta. We obtain so let me calculate what is first xi x. The xi x is 2x by 2, which will gives me x. Xi y, that is a partial derivative of this with respect to y, will gives me 1. Eta x will gives me minus x because the derivative of minus x square is 2x, and eta y it is 1. So we'll have this situation. Now we'll need to calculate ux. As you know that u is a function of two variable xi and eta are the function of x and y. So to calculate u or partial derivative of u with respect to x, we'll have a two paths, that is u xi into xi x plus u eta into eta x. But u xi x and eta x we already calculated here. Let's substitute that value here. So we know that xi x is x, so it is x into u xi plus the eta x is minus x, so that's why it is minus x u eta. Now let's calculate what is uy. That is u xi y plus u eta eta y. Xi y is 1, so it is u eta. Eta y is also 1, so it is plus u eta. Now we need to calculate what is uxx. So for that I will just write down what is ux. Why we need to calculate uxx? Because in an equation we have uxx and uyy. So we have to calculate these two quantities. So for that we have already got the ux, that is x into u xi minus u eta. So uxx, if you want to calculate, then you have to apply the product rule here. The first, a derivative of x, and this function is as it is, so it is u xi minus u eta as it is, plus a derivative of x with respect to x will gives me 1. Now x as it is, and the derivative of this quantity with respect to, so it is del by del x of u xi minus u eta. So this will gives me u xi minus u eta plus x. Here u xi is a function of xi and eta are the function of x and y. And same way we can do it for u eta also. So this will be the derivative of u xi with respect to x we have to do. So it is u xi x plus u xi eta x minus the derivative of u eta with respect to x will gives me u eta xi x plus u eta x. So this will be as it is, u xi minus u eta plus x. Xi x we have calculated is x, so it is x into u xi plus eta x we have calculated it is minus x, so it is minus x u xi eta. This will be plus, so it is minus u eta xi x, and this will be minus, so it is minus minus become plus x u eta. So finally if you simplify this one, we'll get it is x square u xi minus 2x square u eta xi, because this x is multiplied inside and this two terms will add together will become 2, and this x is multiplied here, that will gives me x square u eta plus u xi minus u eta. This is the value of uxx. Similar manner we need to calculate what is uyy. So for that, what is uy we have calculated is u xi plus u eta. So that is u xi plus u eta. So uyy, it is del by del y of u xi plus u eta. So that's why it is u xi y plus u xi eta y plus u eta u eta xi y plus u eta y. This is equal to xi y. We have calculated xi y is 1, eta y is also 1. So both these values are 1. So it is have u xi plus u xi eta plus u eta xi plus u eta. So that will gives me u xi plus 2 times u eta xi plus u eta. So this is the value of uyy. Now substituting this value of uxx and uyy into the equation 1. So substituting the value of uxx and uyy in 1, we get, what is the equation 1 is, we have uxx minus x square uyy. This is the equation 1. The value of x we have calculated from here. Let us substitute that. That is x square u xi minus 2x square u xi eta plus x square u eta minus x square uyy we have calculated here. That is u xi plus 2 u xi eta plus u eta, and the plus another two values is left here, that is u xi minus u eta. And if you can just see that these quantities are cancelled out, but because this x square is multiply and this is of negative sign, so this quantity will not be cancelled, so that is actually added, and this is equal to, we have given it is 0, so this side we have 0, and this quantity is also cancelled out. So the quantity left, it is minus 4 x square u xi plus u xi minus u eta. So this is the things we left. 4 u xi eta, that is this term and this term, that together with minus 4 x square u xi eta. So that's why finally what we have, it is u xi eta will be, you just observe that this two quantity, or I can say this quantity on this other side, and I will divide this 4x square both the side, then we will have it is 1 by 4 x square u xi minus u eta. And again this x is still there, we have to convert this x into the xi and eta. The value of xi, it is y plus x square by 2, and the value of eta is y minus x square by 2. If I subtract this two equation, then this will be xi minus eta, and this y will be get cancelled out, and this will become 2 times x square by 2. So the value of x square we have, it is xi minus eta. So if I substitute that value here, then we will have this 4 into xi minus eta into u xi minus u eta, which is the required canonical form you have. You can just see that it is of the function u of xi eta. So that is the canonical form for hyperbolic type equation, that is u square xi eta is equal to some function of xi eta u xi u eta will be there. So that's complete the first sum. Let us solve the second sum. Reduce the equation, that is y square uxx minus 2xy ux square plus x square uyy equal to x square by x, sorry, y square by x ux plus x square by y uy. So here this is the partial differential equation, and reduce this equation into a canonical form. And solve it if possible. Okay, finally we need to solve also this equation. So to see the solution for this, we need to compare this equation with the standard equation of second order semi-linear partial differential equation. So consider the second order semi-linear P.D.E as R uxx plus S uxy plus T uyy equal to or plus some function of g of x, y, u, ux, ui equal to 0. Comparing equation 1 with equation 2. So whatever equation 1 is, this equation is 1, and this will be the equation 2. We get, you just see that what is r square, what is s, what is t. So what is r will be y square. What is s? That you can say it is minus 2xy. And t will have it is x square. Now we just observe what is s square minus 4rt. S square is the square of this, that is 4x square y square minus 4. X square is, sorry, value of r is y square minus x square. So this will gives me 0. So I can say that the given equation is of parabolic type. Therefore, equation 1 is of parabolic type. So this is the type of the equation we'll consider. And you just observe, if it is a parabolic type, then the canonical form is of this form. That is the second case we have. So now consider, as we have seen in the previous method, that we have to consider the equation, that is r alpha square plus s alpha plus t equal to 0. You consider this equation. Substitute this value of r. So it is y square alpha minus 2xy alpha plus x square equal to 0. So this is the this is a quadratic equation, and you just observe that this is nothing but the y alpha minus x whole square equal to 0. Since s square minus 4rt is 0, it has only one solution, and that we can obtain by solving this, which will gives me alpha equal to x by y. So this is the only one solution is there. So now we need to looking at the solution for this. So this will be the value of lambda you can take. Let's say this is lambda. Now we'll consider the equation dy by dx plus lambda equal to 0. So therefore you have dy by dx plus x by y equal to 0, because that is the value of lambda. Now if I use the separable variable method, this is y into dy plus x into dx is equal to 0. If I integrate both sides, then this will gives me y square by 2 plus x square by 2 is equal to some constant is that. I'll assume that constant is c square by 2. So finally we'll have x square plus y square is equal to c square will be the characteristic curve for that differential equation. So therefore you can assume this x square plus y square as xi square. Sorry, xi. Let's say xi. Now it is up to you what should be the value of eta we can choose in the parabolic type. So let us choose eta is equal to x square minus y square. So this will take any non-zero value you can observe such that this xi and eta should be linear or independent will be. How to check that two functions are independent? You have to check whether the Jacobian will be non-zero. We note that what will be the Jacobian of xi eta with respect to xy? That will be the xi x, xi y, eta x, eta y. The xi x we have 2x, this is 2y, eta x is 2x minus 2y. So this will gives me 2 times xy minus 2xy minus xy. So that will be gives me 4. It is actually 4. 2 to the 4 minus xy minus xy. So it is 4. 8 times. So minus 8 xy. Since x and y both of them is non-zero, because if it is both are 0, then this equation will satisfy. So that is nothing to find out in that manner. So that is this is equal to not equal to 0. So since this is not equal to 0, we can say that this xi and eta is independent. So therefore we can say that n is independent of xi. So in this parabolic type, you have to find out one eta which should be independent from xi. So here it is better to choose the value of eta as x square minus y square. You can choose any other value, but for the simplicity, we will take the conjugate of this value. So now we need to find out what will be the transformation of the given equation. That means we need to change the variable into. So now let us see what is ux. As we know that u is a function of xi and eta, and xi and eta are the function of xy. The ux will be u xi x plus u eta eta x. U xi we already calculated here, that is 2x. So this 2x u xi plus eta x is also 2x. So that is 2x eta x. What? Eta x is 2x and u eta. So that's why it is 2x into u xi plus u eta. Uy in similar manner it is u xi y plus u eta eta y. So that's why we know that the value of xi y is 2y and eta y is minus 2y. So if I can take common 2y from that, we will have u xi minus u eta. Now uxx, if you calculate uxx, that is the derivative of this with respect to x. Here x is already there, this is also function of x, so product will apply. So the first derivative of x will give me 1. So it is 2 times u xi plus u eta is as it is. A derivative of x with respect to x is 1, so only this term is there. Plus 2x as it is. A derivative of this quantity with respect to x. So u xi is there, so it is u xi xi x plus u xi eta x plus now u eta. So u eta xi x plus u eta x. If I substitute the value of xi x and eta x, as we know that xi x and eta x, both of them are 2x. 2x will be common out. We'll have it is this quantity is same. The 2x will appear in each and every term. So the 4x square is common. We will left with u xi plus 2 times u xi eta plus u eta. So this is the things you got. Also now, what is u y? We have already uy, that is u 2y into this. So first, a derivative of y with respect to y will gives me 1. This quantity is as it is, so 2 times u xi minus u eta as it is. Derivative of y with respect to y will gives me 1 plus 2y as it is. Now derivative of this quantity. So u xi into uy xi y plus u xi eta y. Now this is minus, so it is u eta xi y minus u eta y. We'll substitute the value of xi y and eta y. Xi y is 2y, eta y is minus 2y. So 2y will get common out. You will have 4y square. This is u xi. This will be minus 2y and this will be plus 2y. So this will be minus 2 times eta xi and this will be minus, so it will be plus u eta. Still we need to calculate in the given differential equation, it is uxy is also there. So we have to calculate what is uxy. Uxy. So the derivative of this quantity with respect to y. But this is 2x. With respect to y, it is constant. So this 2x as it is. Now the derivative of u xi and u eta with respect to y. So it is u xi plus, sorry, into xi y plus u xi eta into eta y plus u eta xi y plus u eta y. So now what is xi y? It is 2y, so it will be 4xy. We will have 4xy. This is u xi, and here this will be minus. So this two quantity will be cancelled out. The quantity left is last one, that is plus u eta is there. So this is the things you will have here. Now we will substitute all this value, that is uxx, uyy and uxy into the equation number 1. Putting uxx, uyy, uxy in 1, the value of, putting the value of, we get the original equation is, we have given x square, sorry, The equation 1 is y square uxx minus 2xy uxy plus x square uyy will be x square by x ux plus x square by y uy. This is the equation we have. And just observe that what is y square uxx. Uxx is this value. Let us substitute. So we'll have y square into 2 times uzi plus u eta. That is the first things you will have. Plus 4x square y square. And plus this y square is already there. So plus 4 x square y square. You will have it as u xi plus in the middle term it is plus u xi eta plus u eta eta 2 times. So in the middle term it is 2 times. Yeah. So we'll have it as 2 times this minus 2xy is already there plus this 4xy is added to that. So that's why it is 8xy. So we'll have 8x square y square. Inside bracket you will have u xi plus u eta eta plus next is x square is there into uyy. So uyy is this. So this should multiply with uyy. So it is we'll left with 2 times u xi minus u eta in bracket. That means it is in multiplication. 4x square y square. So plus 4x square y square inside bracket. You will have u xi. This will be minus u xi eta plus u eta eta 2 times this equal to, on the other side it is y square by x. Ux, we have calculated ux also. The ux is 2x into u xi plus eta. So that is x will cancel out. So I just write down it is y square into you just see that x will cancel out 2 times this. So it is 2 times u xi plus u eta plus here it is x square by y into uy. Uy value of uy we have calculated is 2y into this where y's cancel out. You will have 2 into x square u xi minus u eta. So this is the quantity we'll have here, and you just observe that 2y square u eta u xi plus u eta will cancel out. This value is cancelled. This value is cancelled with this. Now this 4x square y square will multiply here. So that 4x square y square is also multiplied here. And this is of minus sign. So that's why this value is also cancelled out. This is 8. This 4x square y square into 2 plus 2 times u xi y, and this is also 8. So this will also cancel out. Here I think so we have made a mistake.
Sir, minus neta ave. U neta.
Yes, here it is minus because this is u eta eta is there. Sir, and y.
Sir, uxy ma.
Uxy ma. Here it is minus. Why? Because
eta y minus 2y.
Eta y is minus 2y. So that's why it is here minus. So here it is minus. So this term will become minus. This is minus minus plus. So it is altogether 16x square y square into u eta eta. On the other side, it is 0. So 16. So what is left is 16 x square y square u eta eta equal to 0, because nothing is left on the other side. So finally, what is gives you u eta eta is 0, and that is the required canonical form, which is required canonical form. You just observe that if it is a parabolic type, then the given equation is of this parabolic type. Then s square minus 4rt is 0, then the equation is of this type. That we have here. Now the question is also to solve this, and that is easily solvable, because we have u eta eta. So if I take the integration both the side, so therefore this will gives me u eta, some constant will be there, but that constant is a function of xi, because it is a partial derivative. So if I integrate with respect to eta, the function of xi will appear. So that's why it is f of xi, for where f is some arbitrary function, or it is arbitrary function of xi. Again, if I integrate with respect to eta, so we'll have u equal to integration of f of xi into eta plus another function will appear of xi. So it says g xi. So f and xi, both of them are the function of that. And if I integrate this one, will gives me eta into f of xi, because this f is only a function of xi. So it is actually integration of 1 eta, which will be n or eta, g of xi. So finally you will have it is u equal to eta into f of xi plus g of xi. But what is the value of xi and eta we have calculated? The value of xi and eta which we have assumed is this x square plus y square, and eta is x square minus y square. Let us substitute that. So it is x square minus y square into f of x square plus y square plus g of x square plus y square. So this is the solution for given differential equation, where f and g are some arbitrary functions. Let us solve one more example, that is the third one. The question is reduce the equation into the equation uxx plus x square uyy equal to 0 to canonical form. So here now I am not writing all the details. You just now become an expert to how to find out what is R, S and T. So you just observe that what will be the value of R, you will have it is 1. S you will have 0, and T is x square. So therefore you will have s square minus 4rt. S square minus 4rt is 0 minus 4 into 1 into t is x square is equal to minus 4x square you will have. So that's why this is negative. Since this is negative, we'll say that the given differential equation is of elliptical type. If I can say this is equation 1, then the equation 1 is elliptical type. So as you know that if it is elliptical type, here also we are considering this r alpha square plus s alpha plus t equal to 0. We'll substitute value of r, s and t here. The value of r we have it is 1 s0 t x square. So we'll have alpha square plus 0 plus x square equal to 0. So that's why we'll have x square is equal to alpha minus alpha square. X square is minus alpha square. So you will have two roots here. That means alpha equal to, you will have two roots, plus or minus ix. They are the complex roots. So consider or take lambda 1 equal to ix and lambda 2 equal to minus ix. Now we need to write what is the differential equations are, ordinary differential equation. Now dy by dx plus lambda 1 equal to 0 and dy by dx plus lambda 2 equal to 0. So the value of lambda 1 we have it is ix and lambda 2 we have considered it is minus ix. Again by separable variable method, dy plus ix dx is equal to 0 and dy minus ix dx is equal to 0. So will gives me y plus ix square by 2 is equal to some constant c1 and y minus ix square by 2 equal to some constant c2. So now the value of xi, or I should take xi is equal to y plus I square by 2 and eta is y minus I square by 2. And if you can proceed in this manner by taking xi and eta, the solution contains I, which is a complex, and we are not looking the solution into a complex form. So that's why we need to modify the solution. And as per the theory, you have to consider your alpha and beta, that is alpha equal to xi plus eta and by 2 and beta is equal to xi minus eta by 2. So now consider this or take alpha is this and beta is this. So xi plus eta, so what will be the addition of this two will give? This x square by 2 will cancel out. It will gives me 2y. So the value of beta or alpha is 2y by 2. So the alpha is y. And the value of beta, that means if I subtract this 2, will gives me xi minus eta. So that will gives me I square. So it should divide by 2i because I still left. So that's why it is I will get cancel out. We'll have x square by 2x square by 2. So the answer, final answer will be x square by 2 is left. Just check. So we'll multiply this I also because I don't want I there. So that's why I have did this. Now we need to transform our equation to this alpha and beta. We want to transform equation 1 into alpha and beta. So now need to see what is ux. Now u is a function of alpha and beta, and alpha and beta are the function of x and y. So this is the situation you have. Ux, you will have u alpha, alpha x plus u beta, beta x. So alpha x, what is alpha? We have it is y, and beta is x square by 2. So alpha x is 0, alpha y is 1, beta x is x, and beta y is 0. So this will be 0, and beta x will gives me x, so it is x into u beta you will have. Then it is uy, that is u alpha, alpha y plus u beta, beta y. Alpha y, which is 1, so it is u alpha, beta y, which is 0, so only u beta, only u alpha is there. Now to calculate uxx, uxx is the derivative of this. Product will apply, so derivative of x, u beta as it is, derivative of x with respect to x will be 1, x as it is, a derivative of u beta, beta, that is u beta, sorry, beta alpha, alpha x plus u beta, beta, beta x. So if I substitute alpha x as 0, beta x as x will gives me u beta plus x square u beta, beta. Now we'll calculate what is u yy. That is del by del y of uy, we have alpha, u alpha. So it is u alpha, alpha, alpha y plus u alpha beta, beta y. U alpha we have calculated, sorry, alpha y is 1, so that is u alpha, alpha, and beta y is 0. So only the quantity is left is this. Now from equation 1, what is the equation 1 we have? The equation, given equation is uxx plus x square uyy equal to 0. We substitute this value. Uxx we have this u beta plus x square u beta, beta plus x square uyy is u alpha, alpha equal to 0. So finally you will have it as u alpha, alpha plus u beta, beta equal to minus x square by u beta. And what will be the value of x square we got? It is 2b, because beta is x square by 2. So the x square, value of x square is 2 beta. So that's why if I substitute here that value, it is minus 2 beta u beta. And this will be the canonical form of this type of hyperbolic function, or this is the canonical form of the given equation. And you just observe that if it is the elliptical type, then your equation is always of the form del square u by del alpha square plus del square u by del beta square, or some function of that. So that completes the example, this one also. Let us solve the last example for today. The question is, reduce the equation, that is 1 minus n minus x square uxx minus y 2 y raised to 2n uyy is equal to n y raised to 2n minus 1 uy, where n is an integer, to a canonical form. So here for different values of n, it will have this problem will react differently. For example, if n equal to 0, this term will become 0. Sorry, if n equal to 1, then this ux term will become 0. Because n equal to 1, then this term will become 0. So in that case, you will have the equation which will be of the form uyy is equal to something, and which is already into the canonical form. Let us take this case. So solution, case number 1, n equal to 1. Then given equation reduced to, so this term is 0, you will have y power 2, which is of minus sign, uyy equal to, this is 1, 2 raised to 2 minus 1, so it is y uy. So this will implies uyy equal to minus of 1 by y uy, which is, you just see that what is the value of, it can compare with the canonical form of all the three. We'll see that it is a parabolic type. If you don't, you just compare with r is 0 here, s is also 0, and only the value of t will be there. That value of t is 1. That means s square minus 4rt, if you can calculate, s square is 0, 4 r is 0, and t is 1. So this is negative. So this, sorry, what I did. So it is 0 minus 4 into 0 will gives me 0. So that's my this r square, sorry, s square minus 4rt is 0. So this equation will reduce to, or it is of the form parabolic type. And this is actually a canonical form of a parabolic type. So the given equation equation 1, that is this, is of parabolic type, and the canonical form is uyy is equal to minus 1 by y uy. And you just observe that what is this, y uy plus uyy plus uy equal to 0 is this. And this I can write down as del by del y of y into uy. That means y as it is a derivative of uy, it is uyy plus uy as it is derivative of y with respect to y will be 1, will be 0. So that means the solution for this one, it is y into uy is equal to some function of x, because here x is independent, where f is arbitrary function. So uy is 1 by y fx. So if I apply now separable variable method, this will gives me u equal to fx constant integration of 1 upon y dy plus some another function g will be there, where g is arbitrary function. So you will have u equal to log y into fx plus gx is the final answer for the given equation if n equal to 1. If the n is greater than 1, that is the case number 2. If the value of n is greater than 1, then you can just check what is r. R is n minus 1 square, you just observe here, n minus 1 square. What is s? S is minus y raised to 2n, and t is n into y raised to 2n minus 1. Sorry. And the value of t is this. And s is already 0. So if you check that, s square minus 4rt is 0 minus 4. R is this, n minus 1 square. Y is minus y raised to 2n. So that's why it is minus minus plus 4 n minus 1 square y raised to 2n, which is always positive. Since it is a positive, the given equation is hyperbolic type. It is a hyperbolic type. Okay. So now we need to consider the equation r alpha square plus s alpha plus t equal to 0. Alpha, value of r, that is n minus 1 square, alpha square plus s is 0. T, the value of t is minus y raised to 2n. So y raised to 2n equal to 0. So the value of alpha, you will have y alpha square will be y raised to 2n upon n minus 1 square. So the value of alpha will be plus or minus y raised to n upon n minus 1. But it is plus or minus. So now we'll consider two ordinary differential equation, that is dy by dx plus lambda 1 equal to 0 and dy by dx plus lambda 2 equal to 0. So dy by dx plus lambda 1, that is, we consider this is the value of lambda 1 is y raised to n upon n minus 1, and lambda 2 is y raised to n minus y raised to n minus 1. So we'll have lambda 1, it is this y raised to n upon n minus 1 equal to 0, and dy by dx is minus y raised to n upon n minus 1 equal to 0. Integrate, we'll have y dy by y raised to n plus dx by n minus 1 equal to 0. So if I integrate, this will gives me n minus n y raised to minus n minus 1 plus x upon n minus 1 equal to 0. Is there I have mistake anything here, or is this y raised to 2n बराबर? Okay, equal to some constant c1. Here just change is the negative sign will become here. So it is n y raised to n minus 1 minus x upon n minus 1 c2. Now you call this as xi and you call this as eta, and you will convert the entire equation into the canonical form by doing all this calculation which we have did for above 3 examples. The given equation transformed to the canonical form is u xi eta equal to 0. And this is the canonical form you will get for this example. And so the solution you will have it is u xi equal to some function of eta. Sorry, when you do integration with respect to eta, that will be a function of xi plus u equal to xi into f of xi plus g of eta, where f and g are arbitrary functions. Now, if you substitute what is the value of xi and eta here, and that will gives your final answer. So in that manner, you can, if any differential equation is given, if it is a semi-linear differential equation, then you can able to say that the given equation is whether it is a hyperbolic type, parabolic type, or elliptical type, and you can convert that into the canonical form. So if you have any questions now, you can ask. We'll stop for today.